Vacuum robot is the third and last smart home device to look at in detail in this video. The system usually consists of a charging dock and the robot itself. The dock gets the AC power and converts it to a DC voltage around 20 volt. The charger IC in the robots gets the DC power and charges a 4S lithium-ion battery. A gauge inside of the battery pack can help the device determine when to return to the dock for a recharge. The design considerations of a vacuum robot includes a long battery life. You want your vacuum robot to be running good for several years, so you don't want to overcharge the battery. If you charge it to a much lower voltage, however, you don't fully utilize the battery capacity. The capacity is very sensitive to the charging voltage. I'll talk about it in a later slide. A good way to make sure you don't either overcharge or undercharge is to use a charger that has a good VBAT regulation accuracy. The second design consideration is fast charging. Vacuum robot nowadays can come back to the dock automatically, gets charged, then go out vacuuming again. Faster charging will help them to complete more cleaning cycles and clean a larger area during a day when people are out. We've seen vacuum robots coming with larger battery packs and up to 3 amps of charging current. With this level of current, efficiency becomes important to minimize the heat dissipation. The current regulation accuracy also becomes more important, since you don't want to design for a charging current, but in reality, it charges at a higher charging rate that damages your battery cell, or at a lower rate to make charging time long. There are some popular charges, gauge, and protector for your reference on the lower right corner. Some vacuum robot chargers are implemented discretely with an MCU controlling the switching FETs. The solution has low cost, but also has poor VBAT regulation accuracy. This is why a TI integrated charger comes in as a better solution. Very little variation of the VBAT can result in a big difference in the battery capacity. First off, overcharging can reduce the life of the battery or even pose a safety risk. If you design a VBAT regulation voltage lower in order to make sure that the regulation upper limit doesn't go over the pack maker's guideline, the worst case for the battery capacity happens when the VBAT regulation voltage is on the lowest end. Because of this, picking a charger that has tight VBAT accuracy is both ensuring that you don't overcharge and also to make sure that you don't undercharge. There are several dots with regard to different VBAT accuracies in the graph on the left. Accuracy can translate to the depth of discharge or the utilization of the battery. With an ideal VBAT accuracy, the variation is 0. You can utilize 100% capacity. A plus-minus 0.5% charger in worst scenario yields 98% capacity. A plus-minus 2% accuracy is a good one with discrete solutions, but it only yields 84% battery usage in the worst scenario. With higher accuracy, you can actually save overall cost by picking a smaller battery pack instead of using a bigger one with some untapped capacity. You want to design a vacuum robot that has a long battery life. The secret is to slightly undercharge it. The x-axis of the graph is the number of charging cycles, and the y-axis is the battery capacity. With the family of the curves with regard to different VBAT regulation points, you can see over time, the lower the charging voltage is, the better the battery keeps the capacity. Charging at a higher voltage will give you higher capacity in the beginning, but the battery will soon be degraded over charging cycles. Here are 2 other important design considerations. First, termination current. Look at the green curve, the charging current on the left. The charging current tapers in the constant voltage stage. If it has a high termination current cutoff point, you can terminate too early, leaving a portion of the battery unutilized. If there is no termination threshold, or you terminate with a safety timer, you may charge too full to damage the cell. Pre-charge phase is when the battery is deeply discharged at a low voltage. You want to charge it at a lower rate first to make sure it's a good cell. It is called the pre-charge phase. If you bypass this step and charge a deeply depleted cell with the fast charging current, it may not be safe. Switching frequency. The higher the frequency is, the smaller passives you can use. Take 2 TI chargers for example. The BQ24725A and the BQ24610 switch at 750 kHz and 600 kHz respectively. Comparing to the very low 50 kHz of a discrete solution, TI chargers' inductor sizes and their price points are much lower. Standalone charger versus host-controlled charger. Standalone chargers are straightforward to design since the charging parameters are set by the external resistors and capacitors. Host-controlled chargers allow more flexibility for charging as the host can control the charging with the software. Safety is another big thing to consider when you design a battery charger. TI chargers offer a full set of safety features. If you look at the BQ24725A, for example, on the input, we have overcurrent protection, overvoltage protection, and short protection. And there's also an IC thermal protection. Inductor and FET short protection is also included. On the battery pack side, the battery overvoltage, short, and reverse protection are included. Compared to a thorough protection scheme offered by the charger ICs, discrete solutions usually offer less or no protection. The discrete protection has to be implemented by MCU controlling extra discrete components. This will increase both software and hardware design complexity. The response time is critical for protection as well. A discrete solution usually takes longer time to take protective actions than the charger IC. To summarize, here are several TI chargers' benefits for vacuum robots versus the discrete. First, you can save cost in battery pack by using a high VBAT accuracy charger IC. You can also use a smaller and lower cost inductor with charger IC's higher switching frequency. You can also achieve a good battery runtime and lifetime with good VBAT accuracy. Then the host-controlled and standalone chargers offer two styles for you to design. The last but not least, safety. TI chargers offer a full set of safety features to help you design a worry-free charging system.